So vector valued functions, we were able to do things like take the derivative of a position function to get to the velocity and acceleration function successively. So it would make sense that we could also reverse that process and integrate as well. So if we're given a function or a vector valued function, we can integrate by integrating the horizontal component and the vertical component each individually to come up with our new vector. So going from velocity to position, we would either integrate with an indefinite integral or with a definite integral. So that's the case if we have an indefinite integral on the left, and it works the same way as if you were doing it with regular functions. So I'm going to just stick the limits of integration of a and b into the formula that you guys see on the left, and that's the only difference between the left and the right. So let me go ahead and write y of t, integrate that as well. And so let's work with our first example here. You're given the velocity vector is given by, and again, sometimes this is written in component form as negative 3t squared minus 8t minus 4, comma 2t cubed. And just like with regular functions, when I'm given a vector valued function, they might expect me to do an indefinite or definite integral. In this case, they do say that when t is equal to 2, the position vector is 4i plus 8j. So that's essentially giving you guys what we are used to calling an initial condition. So all of this is my initial condition. Find the equation of the position vector. So what we're going to do is simultaneously integrate the x and the y at the same time, remembering to add c such that we are solving for that. So let's say we're solving for x of t, y of t, and let's go ahead and integrate each one of those components. So let's start with this. So what I'm doing is integrating term by term. If I integrate negative 3t squared, I'm incrementing 2 by 1, so 3, dividing by 3, and I get that this is negative t cubed. If I integrate negative 8t squared, divide by 2, so negative 4t squared, and then minus 4t. And remember, that's just the horizontal component. I'm going to add c to that. And then now integrating separately or at the same time simultaneously, though the vertical component, we have 2t cubed is the same thing as increment 3 by 1, 4, so 1/2 t to the 4th, and then plus c. So you're solving now for the horizontal and vertical component of your position vector. We're going to use the initial condition stated at time t equals 2, x is 4, at time t equals 2, y is 8. So let's go ahead and do our substitution. Let's do the horizontal first. So if I set 4 equal to negative 2 cubed minus 4 times 2 squared minus 4 times 2, and then plus the c. So 4 equals negative 8 minus 16 minus 8 plus c. So simplifying that, we get negative 32. So we get 4 equals negative 32 plus c. So solving for c, we get c is equal to 36. And that's just for the horizontal component of your position vector. Now if you do the same thing, 1/2 so this is separated into two parts, 1/2 2 to the 4th plus c must equal the 8 that you guys see as the initial condition. And so if we take half of 16, we do get 8. So 8 plus c is equal to 8, or in other words, c is 0. So our final answer, the position vector, x of t, comma y of t, must be equal to the functions negative t cubed minus 4t squared minus 4t plus my constant 36, comma 1/2 t to the 4th plus 0, or we don't have to write that out.